We talked before about constant numbers and we said that they do not change. So for example, negative 4 on the number line is always going to be between negative 5 and negative 3. It's always going to be between negative 3.5 and negative 4.5. It's not going to change. It's a fixed place on the number line. Just like 3, just like 0, just like any number. It cannot change. Its position is fixed. And remember we said those were constant numbers. So we'll go ahead and write that out real quick. Now, what about if we don't stipulate what the number is? What if we just draw a number line and we have an empty box? You can fill that box with whatever you want to fill it with. So it's on the number line, but we don't exactly say what's in it. So let's say we want to fill it with 11, or let's say we want to fill it with 0, or we want to fill it with negative 5. In other words, it can take on any number it wants to be. It can be a fraction, 4/5. Or it could be pi, like we talked about before, which is approximately 3.14, and keeps on going. Okay, this type of number changes, and we leave it empty because we don't know exactly what it is, but it can take on many different numbers. Now, usually what happens is, in math, instead of drawing a box, we draw a letter, and that letter represents all those numbers we just looked at. So that X, or any other letter we use, sometimes A, sometimes C, can be any number it wants to be. And the word that we're looking for here, is variable. Okay, again, we can also use another letter like A, and that could represent any number, a number. And it could be 2, 4, 5, 7, whatever, and it's just a variable. We could also use Y, and that could represent any number on the number line that we choose. Sometimes we even use Greek letters. This is the letter delta, but for the most part I kind of like to stick to English letters just because they look a little bit more recognizable. So the best definition I have for you guys is a simple one. A variable is a number that changes. Okay? As opposed to a constant. A constant number cannot change. So let's look at some real life examples. Let's talk about the money in your bank account. Now, I doubt anybody's money in their bank account stays the same. It's always changing, right? You either withdraw money or you deposit money. So let's say you have $1,000 and $1,006 in your bank account, and then you deposit your paycheck. Now you have over 2,000, right? But let's say you have to fix your car and it costs $2,000. Well, then it goes down to $3. In other words, that number is constantly changing. That would be another example of a variable. How about your height? When you're born, you're certainly really short, right? And then let's say you grow to 3 feet and you keep growing, you get up to 4.5 feet, and then finally you reach 5 feet and maybe you keep growing, growing, growing. Again, that's an example of a variable, your height. That will be always changing. Or gas in your tank. Okay, when you fill it up, maybe it holds 10.4 liters, but as you drive it, it burns gas. And it's going to get down to 6 liters, and then finally, maybe if you keep driving it long enough and you don't fill it up, it will have 0 liters in the tank. So therefore it is a variable, it's a number that changes. So let's go ahead and look at some examples and try to identify numbers that change. These are the same slides we use with the constant numbers, although now we're going to identify which ones are variable, which ones that change. Well, looking at it, we know that 10 and 8 stay the same, but we know x can change. And like I said, usually we use letters to represent variables, just because they're symbols that aren't numbers. I mean, that's all really the reason we do it. And sometimes, of course, the letter itself might be like short for something, like H for height, for example, which I believe, yes, like right here. See, H is short for height, so that makes sense that we'd use the letter H. G is short for gas, so we can use that for a variable. And M represents money in your bank account, so why not use that instead of X? A lot of times it just makes more sense to use those letters. Okay, let's look at this example. This should be actually example 2. Okay, so which one of these are variable numbers? We talked about that I and E are actual specific numbers. I is square root of negative 1, and E is 2.718. It goes on forever. Y, however, changes. It's not a special letter in math. I, E, and pi are basically the main three examples, but basically any other letter it can be a variable number. Alright, which of the following of these numbers are variable numbers? Alright, so we have A, that can change, and again, like I said before, that could just mean any number. And any starts with the letter A, so we just use the letter A for any number or a number. Okay, everything else here is constant, including pi, but B is a number that also changes. And why would we use B? Well, if we already used A for any number, the next letter in the alphabet is B. So it might represent a different unknown number or a different changing number. So A and B, maybe even C, who knows? Okay, which of the following of these are variable numbers? This is example 4. We know E is constant. We just talked about that. 4/3 is constant. 4C, now that actually changes. Now 4 doesn't change, but when you multiply it by C, a letter that we did not stipulate what it equals, that means it's a variable. 4 times a number that changes also changes. So therefore 4C would also be a variable number. It actually would be an expression because it involves more than one number, but it changes, so it varies. Okay, F would also change. It's not a special number like E is, so it's a variable. Now M equals 2, like we talked about before, that's constant because we're stipulating M equals 2, so we cannot say that's a variable. M will always be equal to 2 if we set that forth in the beginning of our mathematical endeavor. And negative 11.0 certainly stays the same, so we have to leave that also. So there's the only two on that slide that change. Everything else stays the same. And in a nutshell, that's what a variable number is. It's a number that stays the same. I'm sure you can think of many more numbers in the real world that change. Like I said before, most all numbers in the real world are variable numbers. Okay. The number of pages in a book. I mean, every book is different, right? So that number will always change. The number of kids that people have. I mean, some people have 2 kids, some have 0, some have 5, some have 10. The year. I mean, what year is it? You know, year's always changing. What time is it? So many numbers in the real world change, and those are called variable numbers.